Hi judges, thank you for taking the time to review our proposal, which is removing ZooKeeper from Pulsar. First, let us briefly introduce our team. We are the minimalism team because we want to keep things effective and simple. In this video, we are going to show you why we remove ZooKeeper, how we get things done, and the future plans. Let's jump right into the problem. If you ever worked with Pulsar, you know that ZooKeeper is an essential part of Pulsar for storing metadata. We have a lot of respect for ZooKeeper, but we got a requirement about not depending on it, and the user's pain points are as below. The first is, it's hard to maintain. The interaction with ZooKeeper is complicated in a large Pulsar cluster where many nodes connect and need to scale horizontally. The second is, it's difficult to scale. When starting a Pulsar cluster, you need to initialize metadata. As business expands, loading more data from ZooKeeper takes a long time. The third is, it's challenging to keep stable. If ZooKeeper goes down, everything becomes unavailable and all Pulsar node caches are wiped. And in the long term, we think removing it brings many advantages. Like, it simplifies Pulsar's architecture and makes it more independent. It improves performance and scalability of Pulsar. And it reduces the complexity of deployment and maintenance. So how we remove it? After comparing several solutions, we've made two changes. The first change is to bring metadata storage and management into Pulsar by replacing ZooKeeper with Raft. Like ZooKeeper, Raft stores metadata in a distributed way and makes metadata durable. But better than ZooKeeper, Raft groups store metadata more efficiently and it will not be the scalability bottleneck. Besides, Raft has been proven to be safe and efficient in etcd. After embedding Raft KV inside BookKeeper, the metadata of brokers and bookies is stored in BookKeeper, which brings metadata storage and management into Pulsar. The second change is to provide a flexible way to handle metadata by introducing a unified Metadata API for metadata abstraction. Currently, brokers and bookies access metadata via different interfaces. If we want to use other metadata backend services, we need to implement the interface to the metadata backend services separately, which is not an effective method. So we come up with an elegant solution. We use the metadata store interface for both brokers and bookies, and implement a metadata driver adapter over the metadata store interface. In this case, no matter what the metadata backend service is, both brokers and bookies can access metadata only with the metadata store interface. Now we are going to show you the first glimpse of running a Pulsar cluster without ZooKeeper and going through basic use cases of producing and consuming messages. First, start BookKeeper. Number 1, change the BookKeeper's configurations. Change some configurations to Graft. Number 2, start the first BookKeeper. Now start the second BookKeeper. And then start the third BookKeeper. Graft is started with a BookKeeper each time. Now without ZooKeeper, 3 booking pool nodes start successfully. Number 3. Check whether the metadata of BookKeeper is stored in Graft. As can be seen from the output, the answer is yes. Number 4. Check whether the BookKeeper can read and write. Yes, the BookKeeper can read and write successfully. Second, start a broker. Number 1, change the configurations of broker. Change some configurations to Graft. Number 2, initialize the metadata for the cluster. Number 3, check whether the metadata of the Pulsar cluster is stored in Graft. As can be seen from the output, the answer is yes. Number 4, start a broker. Now, without the ZooKeeper, the Pulsar service starts successfully. Third, we want to produce and consume some messages. You can see we produce 100 messages like "Hello to no Zike." And we received 100 messages successfully. Last, we want to check whether the Pulsar admin tool works. We use the Pulsar control. Yes, it works. Now, we've demonstrated that without the ZooKeeper, we can start a Pulsar cluster, then produce and consume messages successfully. Due to the limited time, we have finished some of the planned work. The source code and implementation details are available on this website. Feel free to check them out. And we will finish the following tasks in the future. The first is, we will contribute the changes to the Pulsar community. But before it becomes production ready, we need to make some enhancements, like improve raft metadata store implementation, provide better abstraction of the Pulsar metadata operation, provide a better integration between Bookie and Raft KV, just to name a few. The second is, for the metadata backend service, we are also considering using another implementation to allow more partitions, For example, we can use etcd or implement a cloud-native distributed metadata and distributed log system on Kubernetes. Nowadays, more organizations are moving to a cloud-native environment and need quicker deployment, greater scalability, and better performance. Removing ZooKeeper from Pulsar is in line with this trend. As always, Pulsar is evolving all the time. Our plan is a part of this evolution and is a good start from zero. We believe with the efforts made by the community, this milestone will be achieved in the future. At last, a special thank you goes to Hackathon organizers, judges, and everyone who has helped to make this happen. Thanks again.